Alright guys, welcome back. In today's question, we have a golfer that's hitting a golf ball with an initial velocity of 160, an angle of 25 degrees with the horizontal. Knowing that the fairway slope downward at an average angle of 5 degrees, so we know that this slope makes 5 degrees with horizontal, and we need to determine the distance d that the golfer and point B where the ball first lands. So looking at here, we have a right triangle D. So what's happening in here, before we start, we need to set our origin for this question. We're gonna put the origin at point 8, so this will be our X, and we'll call this Y. So what's happening in here, we have this right triangle that I'm gonna show in yellow. We have this right triangle here, which we know the hypotenuse is D, and let's call this side XB and the other one YB. And from the question, we know this angle is 5 degrees, which means we have 5 degrees in here as well. So we know the initial velocity in here is 160 feet per second. And let's find our velocity in X and Y direction. So if we want to go with X, what we have for X will be the initial velocity times cosine of 25, which will be 160 times cosine of 25. We also have the initial velocity in y direction, which we have a constant acceleration, and this time will be sine of 25 degrees, 160 times sine of 25 degrees. That's what we have. And also, if you want to find the xb and xy that I showed earlier, we see that our xb will be simply d, which is the hypotenuse of the right triangle, times the angle 5 degrees that we have. So d times cosine of 5 will be our xb. And if we want to find yb, we'll see that y is in the negative side of y. So we have a negative sign in here, will be d times sine of 5 degrees. These are all information that we can get from the question before going to our horizontal and vertical motions. Let's start with the horizontal. So we know in horizontal motion, we are going with the constant speed, which means there is no acceleration, and the formula that we can use is we can go with our xb, the initial distance that we have, plus velocity time, initial velocity in x direction times the time. Let's call the time tb, which is the time that we reach at point B. And what we can get from here, we know that xb is d cosine of 5 degrees, which we found earlier, equal to the initial x would be 0 since this is at our origin, so there wouldn't be any initial x. And for the velocity, we already found it will be 160 cosine of 25 degrees times tb. And from here we can find tb, which will be d times cosine of 5 degrees divided by 160 cosine of 25 degrees. The time will be the same in both motions, horizontal and vertical. So we can use this t in our next formula that we have. So if we move on to vertical motion, we have constant acceleration, which is g, acceleration of gravity. So for that, we have the formula of y, which if we call it yb, we'll have the initial y, which is again 0 because we are that would be our origin, which we call it 0, and we'll have the same t, so this will be 0. So we know that g will be 32.2 foot per square second. So 9.81 is 4 meter per square second. But since our all of our dimension that we have are based in foot, we go with the 32.2 for g. So we found yb like in the previous step, which was minus d sine of 5 degrees. We also found the initial velocity in y direction, which was 160 times sine of 25 degrees. So we have the time in here, and if we plug in what we found for tb in this equation, we'll have one equation that only has a d as an unknown. So we can find the at the end. So we'll have sine of 5 degrees, we'll have 160 sine of 25 degrees. I'm just gonna put what we found for TB, which was the cosine of 5 degrees divided by 160 cosine of 25, and same for the other one, cosine of 5 degrees, 160 cosine of 25. So what we can do in here is, so I'm just gonna put the in one side of the equation, and what we have in here, we have this fraction in here, and on the other side of the equation we'll have 160 sine of 25 times the cosine of 5, 160 cosine of 25, and we'll have the sine of. So if we multiply these equation by 1 divided by d times cosine of 5 degrees, what we end up having for the left side of the equation is, so we're gonna lose one of the d's and also one of the cosine of the 5 degrees, so we'll have cosine of 5 degrees divided by 160 cosine of 25 degrees. And if we look at the right side of the equation, we have 160 sine of 25 divided by 160 cosine of 25, which is simply tangent of 25, and the numerator will be cancelled out with what we are multiplying in the equation, which is 1 divided by d cosine of 5 degrees. So that would be pretty much for the first. And the second one we have here, d sine of 5 degrees divided by the cosine of 5 degrees, which will be the tangent of 5 degrees. And that's pretty much it. If we want to find d in here, we'll have 2 divided by g, cosine of 5 degrees, so g will be 32.2 times cosine of 5 degrees. And we also have 160 cosine of 25 degrees squared, and the rest will be the tangent of 25 plus tangent of 5. And if you calculate this, we'll get 726.06 feet.